What if Earth is not special? What if somewhere in the universe, there is another planet with oceans, clouds, and a stable atmosphere? Not in science fiction, but in real astronomical data, 48 light-years away from us. Astronomers have discovered a planet that may be one of the most promising, Earth-like worlds ever found. Its name is LHS 1140b. This planet is not a guess. It is not imagination. It is not a rumor. It is a real exoplanet observed by real telescopes, including the James Webb Space Telescope. But does it truly resemble Earth? Could it hold liquid water? And more importantly, could it support life? Let's break down the science step by step. LHS 1140b is an exoplanet, meaning a planet that orbits a star outside our solar system. It is located approximately 48 light-years away in the constellation Cetus. The planet orbits a red dwarf star known as LHS 1140. Red dwarf stars are smaller and cooler than our Sun, but they are the most common type of star in the universe. LHS 1140b is classified as a super-Earth. This does not mean it is similar to Earth in every way. It simply means that it is larger and more massive than Earth, but smaller than gas giants like Neptune, based on current measurements. The planet is about 1.7 times the size of Earth. It is roughly 6 to 7 times more massive. These properties suggest that LHS 1140b is likely a rocky planet, not a gas world. And that matters, because life as we know it requires a solid surface. One of the most important reasons LHS 1140b gained attention is its position. The planet orbits its star within the habitable zone. The habitable zone is the region around a star where temperatures could allow liquid water to exist on a planet's surface. Not ice, not steam. Liquid water. Because red dwarf stars are cooler than the Sun, their habitable zones are much closer to the star. LHS 1140b completes one orbit in about 25 Earth days, yet still remains within this life-friendly zone. This balance is critical. Too close, water evaporates. Too far, water freezes. LHS 1140b appears to be in the right range. A planet without an atmosphere is almost always hostile to life. An atmosphere regulates temperature, protects from radiation, enables water stability, supports chemical reactions needed for life. Using transit observations, scientists studied how light from the star passes through the planet's atmosphere. The data suggests that LHS 1140b may have a thick, stable atmosphere. This is a huge discovery. Many exoplanets around red dwarf stars lose their atmospheres due to stellar flares. LHS 1140b, however, seems to have survived this process. Some models even suggest that the atmosphere could be rich in nitrogen, containing water vapor, possibly carbon-based gases. This does not mean oxygen has been found. It means the planet has the potential to support Earth-like chemistry. Let's be very clear. No telescope has directly photographed rivers or oceans on LHS 1140b. However, scientists infer the possibility of water based on density calculations, atmospheric modeling, thermal behavior, planetary composition. Some studies suggest that up to 20% of the planet's mass could be water. This raises the possibility that LHS 1140b may be a water-rich world, a planet with deep global oceans, or a world with subsurface liquid water. All three scenarios are scientifically plausible. And water is not just important, it is essential. Every form of life we know depends on it. The James Webb Space Telescope, JWST, changed everything. Unlike older telescopes, JWST can analyze atmospheric chemistry with unprecedented precision. It allows scientists to detect water vapor, carbon dioxide, methane, other molecular signatures. LHS is now considered one of the top priority targets for future JWST observations. Why? Because if life exists anywhere nearby, this planet is one of the best candidates. Not because life is confirmed here, but because conditions are right. Life does not require perfection. On Earth, life exists in deep oceans, volcanic vents, frozen tundras, acidic lakes. What life needs is energy, chemistry, stability, time. LHS 1140b has existed for billions of years. That is enough time for complex chemistry and potentially biology to emerge. However, there are challenges. Higher gravity, stellar radiation, unknown atmospheric composition, So the honest scientific answer is this: LHS 1140b could support life, but we do not yet know if it does. No, and scientists are very careful about this. LHS 1140b is not Earth 2.0. It is not a backup planet. It is not a destination. But it is something equally important. It is proof that Earth-like planets are not rare. It shows us that rocky planets can survive around red dwarfs, atmospheres can remain stable, water-friendly conditions can exist beyond our solar system. That changes how we understand the universe. Future observations will focus on atmospheric composition, surface temperature mapping, seasonal variations, potential biosignatures. If gases like methane and oxygen are detected together, it would be revolutionary. Not proof of life, but the strongest hint ever found. LHS 1140b is not about aliens. It is about perspective. For thousands of years, humans believed Earth was unique. Now we know planets are everywhere. Habitable worlds may be common. Life may not be rare. LHS 1140b reminds us of one simple truth. The universe is larger, older, and more capable than we ever imagined. And Earth may not be alone.